All right, let's take a look at the idea here today. Well, let's start off with some angles. So if we look at this guy, what's his angle there? I don't know. Let's guess maybe it's open 40 degrees. The opening there is 40 degrees. And then here, well, that looks like a right angle, so that's probably 90 degrees. Here's an obtuse angle. It's gone past 90, a little bit further. So that guy's what? Maybe let's go with 120, somewhere in there. And this guy's even more of an obtuse angle. So maybe he's, I don't know, let's go with 150 degrees. So we have angles. We always talk about angle openings. Now, what we're going to do is angles will always open up from pointing towards the right like this. So we're always going to imagine that it's going starting here. This is always the starting point. And it opens for right now in that direction. That's the positive opening. So we're always going to be opening that way. All right. So if we look at a typical circle, we're always going to be imagining this is sort of our baseline right here. And we'll be opening up. And if we open to here, we could say, oh, that's a 30-degree angle. Okay. Well, let's talk. What we're interested in is this piece here, that length of that guy. Now, the length of that, we're going to actually refer to as a radian. Okay, that's what a radian is. It's this opening right here. Now, we could get a lot more technical with it, with everything that it is, but we're going to sort of keep it simple for us. Okay, so a radian is this distance around. Now, if we think about that, let's imagine that from here to right here is a perfect one. And that's what in a unit circle that we'll be basically sort of learning here, we always assume that it's a unit one. Okay. Now we want to open this up. Now we know if we go all the way around, how many degrees would that be? 360 degrees. And we know here is right here is 90 degrees. Well, what do we call that? The distance all the way around a circle. Is that air? No, wait, that's not air. What is it? Yeah, that's circumference. The circumference of a circle is the distance all the way around it. Now, the circumference, do you remember the formula? It's pi times the diameter, or 2 pi r. Well, in this case, the radius of the circle is 1, which means the diameter is 2. So the distance all the way around is 2 pi. So if you and I, again, we always start pointing that way. If we go all the way around, which when I dunk on somebody, I like to do that all the way around. We call that what? A 360. Well, all the way around is basically 2 pi as far as our distance on this outside of the circle. So all the way around is 2 pi. Well, what if we only went halfway? Well, if all the way around is 2 pi, halfway to right here is what? Pi. So if we imagine opening up 180 degrees, basically we're always pointing towards that opening. If we open to here, that's pi in radians or 180 degrees. So 180 degrees and pi are the same thing. One is in degrees, one is in what we call radians, because from here, walking all the way around that circle of a unit of 1, I would have walked in 3.14 feet or 3.14 units or whatever, meters, miles, whatever we want. Now, if that's the case, and we know that's pi, let's take the 180 out of it. What is it if we've only gone 90 degrees, which you and I know 90 degrees would be right here. So what if we just open up, we're pointing there and we open up to right here? Well, that's 90 degrees. That's what we've always known it as. But if in radians terms, we want to know what's that sort of length right there. Well, if that's half of that pi, so it's just half of a pi, or pi divided by 2. And again, that's 3.14 divided by 2. But we refer to it in radian terms as pi over 2. We're going to refer to our radians always in terms of pi, because all the way around a 360-degree turn is 2 pi. So we're going to just, we're going to refer to it in terms of pi. It makes life a lot easier. Now, if you think and you wanted this in little terms of numbers of like 1 and 2 and 3 and so forth, having trouble erasing, board's not doing well. Well, what is 2 times pi? That's 6.28, right? So all the way around, you would have walked 6.2. If this is a unit of 1, let's say 1 inch, or let's say 1 mile. If you walked all the way around a circle that had a radius of 1 mile, you would have walked 6.28 miles. So really 1 is like right here, and right here we know is 3.14. So 3 is here and 2 would be here. We could divide it, but we don't want to do that. We don't like to write it. We like to put basically most of our common things in terms of pi. Okay, so radians is going to be in terms of pi. We flip back and forth between them. Now, here's the key. We have all these things that we said a minute ago. Let me erase these. We had all these degrees and everything. Let's write those down. Well, we know here is 90 degrees. Let's turn the pen. That might help us. This is 90 degrees, and here we'd be opening 180, and down here add 270, and here all the way around 360. Well, we said this is pi radians right here, pi. Up here is pi over 2, which is the same as 90 degrees. Down here would be 1.5 pi's, or 3 pi over 2. And then all the way back here is our 2 pi, or 360 degrees. Those are all the same. Well, if they're all the same, just like 1 foot equals 12 inches, we can transfer between them. So this is what we're going to use to transfer between degrees and radians. When we got to switch things from radians to degrees, we're going to use this ratio right here, and vice versa. So what do I mean by that? Here's what I mean. Let's say somebody said, hey, Mr. Hickam, 30 degrees is equal to blank radians. How many radians? If I have a 30-degree opening, meaning an angle that's open here at 30 degrees, and again, I apologize, the board is really messing up today. 30 degrees there. What is that in terms of radians? Well, here's all I'm going to do. I'm going to go, hey, I got 30 degrees. I'm going to multiply it by, well, I want to change this into radians. What relationship do I know? I always know that 180 degrees is the exact same as pi radians. Or if you need pi on top, come on, Mr. Board, over 180 degrees. Since these are the same, anything divided by itself is 1, so you can multiply by it. So in this case, I'm either going to multiply by 180 over pi or pi over 180. Since I want to get it in terms of radians, I'm going to put the radians on top, the degrees on the bottom, and that way the degrees cancel with degrees. We get 30 pi over 180, but we do need to simplify that. Well, you can take the zeros off by dividing by 10, and you get an answer of what, 3/18? No, we're not going to say 3/18 because that goes further. Divide by 3, you get what? Pi over 6. 30 degrees is pi over 6 radians. Now, again, we don't want to put it as a little number. We like radians in terms of pi. So that's all we're going to do. Whenever we're trying to go degrees to radians, we're going to multiply by pi over 180 because they're worth the same thing. Now, we can do it backwards. What if somebody said to me, hey, I don't know, let's say I have pi over 3, and I want you to change that equals how many degrees? Well, I'm simply going to start with what they gave me, pi over 3, and I'm going to multiply it. I want to change it to degrees, right? I want to get it in degrees. Well, I know 180 degrees is the same as pi. You're always going to be multiplying by either 180 over pi or pi over 180, depending on what you're trying to get. In this case, I'm trying to get degrees. That's why degrees is on top. The pi's will cancel. You get 180 over 3, which is 60 degrees. And again, you can look at the homework problems where I do most every one of them for you to sort of get this idea. It's something new, so it's going to take us a while to play with it to get it down pat.